Hi, I'm Seoyoung Kim, and I'm glad to present our work, How Older Adults Use Online Videos for Learning. Although it is important for older adults to pursue lifelong learning, it is difficult for them to pursue learning because they often face physical and financial difficulties to pursue learning offline. Online videos such as MOOC videos or even various instructional videos on YouTube have been pointed out as potential media for supporting older adults learning as they are widely available. However, while much research has investigated on how typical users watch to better support their learning, older adults may show different watching patterns due to age-related factors. Understanding how older adults watch could help them to better use online videos for learning. Thus, we aim to understand how older adults use online videos for learning. These are our research questions, which are about their motivation, watching patterns, and difficulties. Here we define older adults as people who are having or are about to have a later stage of life. So considering the retirement age in Korea, we defined older adults as those who are aged 55 or older. To understand how older adults use online learning videos, we took a mixed methods approach, where we conducted interviews and large-scale log analysis to gain a comprehensive understanding. For the interviews, we interviewed 13 older adults who had experience watching online videos for learning within 6 months. And then we conducted a semantic analysis. For the log analysis, we analyzed video event logs of KMOOC. We tried to understand how older adults watch MOOC videos better by comparing how they watch differently from non-older adults. Among all users, 2.8% of the users were older adults. Now I will cover the results of each of the research questions. For our RQ on why and what they want to learn, our interview participants wanted to learn something that relates to their personal interests, hobbies, or needs in their daily life, while only few wanted to learn things related to their work. This resulted in only few participants learning STEM subjects, while most of them were largely limited to learning at the surface level instead of learning the theories. This aligns with our log analysis results, which showed that they take more courses in humanity and medical science, while taking fewer courses in STEM compared to non-older adults. Also, we found that they take more elective courses and fewer major courses than non-older adults. This may be because they want to learn something that relates to their personal interest, as shown in our interview results. Next, to understand how they watch videos, we first investigated how much they interact with the video. For interaction, we focused on watch, pause, and skip forward or backward, as they have a direct connection with the flow of how users consume video content. From the interview, we found that they do not interact much overall. This was because they didn't need to fully understand, as only few were watching for their work. And also because they don't know how to interact or felt uncomfortable interacting with the video. One participant didn't know about pausing or other functionalities, so they would watch the video from the beginning again. Particularly, many participants said that they didn't skip forward at all, as they prefer not to miss or skip anything. Even for the same jump, the intention behind performing a long jump could be different from a short jump. So, for log analysis, we defined 12 detailed interactions by splitting each of the 4 video interactions into 3, short, medium, and long, based on the distribution of the length or duration of each interaction. Then we used linear regression to identify the relationship between the frequency of each detailed interaction and the user's age group. This graph shows the coefficient of being older adults for each of the detailed interactions. As you can see, all of them have negative values, which means that they perform all detailed interactions less than non-older adults. Also, you can see that they perform large sig forwards significantly less than non-older adults, which aligns with our interview results. Furthermore, to understand how they interact with the video at a macro level, we performed sequence clustering using the watching sequence patterns that are composed of the 12 detailed interactions. This table lists the resulting clusters as well as the odds ratio of each cluster. You can see that the odds of older adults watching in the pattern of cluster 5, which is to watch at a longer pace, just pausing for a long time once in a while, are 1.3 times that of non-older adults. Also, the odds ratio of clusters 2, 3, and 6 were below 1, meaning that they are less likely to watch in a constant skipping or skimming manner than non-older adults. We also investigated how much they watch a single video. Through interviews, we identified that they tend to always watch until the end due to their desire to learn. We also analyzed one's coverage of a video, which we define as the sum of all the watched parts out of total video length. Results show that they cover significantly more of a single video than non-older adults do, which align with the interview result. Also, as you can see in this box plot, older adults cover nearly 90% of the video on average. Finally, for the difficulties they face difficulties due to the characteristics of the video medium and the technology itself. For instance, one participant mentioned learning through a video is hard since the view gets blurred after watching for 20 minutes. They also face difficulties due to video-specific issues. For example, one participant mentioned that they would see slowly as they get old, so they have difficulties seeing the letters passing away too quickly. In sum, our results show that older adults watch differently from non-older adults, such as interacting less, being unfamiliar with video interactions, being less likely to skip forward or skim, and covering more parts of a video. This could be because there's a generational difference in the mental model of online videos. While older adults are familiar with watching passively like TV, non-older adults could be more familiar with interactive media. Thus, we believe that it's necessary to go beyond the current one-size-fits-all of online videos to better support older adults' learning. For this, we present design guidelines for creating older adults-friendly videos and their platforms based on our findings. Here, due to the time limit, I'll just cover one of the design guidelines, which is to make a video recommendation engine specialized for older adults. Our results show that older adults are less likely to skip forward, drop out less in the middle, and experience physical difficulties from long watching. This suggests that they are more likely to waste their time watching the video, although they do not like it, making the cost of false positives to be higher. So, among various metrics to evaluate recommendation algorithms, reducing false positives would be a relatively more important metric when designing recommendation engines specialized for older adults. For more design guidelines and results, please refer to our paper. Thank you.